Hello! Welcome to the first video on this channel where we will be discussing this thing. This thing is the Portuguese man of war, also known as the blue bottle jellyfish, although, full disclosure, I swear it's not a jellyfish. First thing, why should you give a crap what I have to say about the Portuguese man of war? For a couple of reasons. Or you just don't care and you leave this video and whatever, I don't care. You do you. If you don't want to hear what I have to say about the Portuguese man of war, feel free to leave. Up to you, really. But I'm Gabby. I'm 26 years old. I have been interested in marine science since I was 12 years old, and I've been working in some kind of science communication field since then. I'm currently getting my master's degree in marine biology. I'm focusing on corals and invertebrates, of which this vertebrate ain't got no bones. So it does look rather jellyfish-like. It's got the float and the tentacles. It can sting you. So your next question might be, where do I get off saying it's not a jellyfish? Well, to understand why I say that this is not a jellyfish, you first need to understand the order of classifications. So that's your standard kingdom, phylum, class, order, all of that. I really hope I said those in the right order because I can never remember what the order is. And the knowledge that jellyfish is a common name. And I love a common name. We all love a common name. But, as evidenced by the fact that this thing has two common names, Portuguese man of war and blue bottle jellyfish, it's not always the best way to describe something if you want people to know exactly what it is you're talking about. If I was giving this talk to the broader scientific community, and not to you people on YouTube, I would probably not call this a Portuguese man of war or a blue bottle jellyfish. I would call it Physalia physalis, because that is its species name. And then I know that there is no confusion about what it is that I'm talking about. But for you guys, I'll just call it a man of war because Physalia physalis means nothing to you. Which is fine. I'm going to be totally honest. Until about 3 weeks ago, Physalia physalis would have meant nothing to me. Because I didn't know what this thing's scientific name was. I just knew it by its common names. Anyway, common names. Not a great way of describing something. And the reason for that is because we like to group things based on what they look like or how they act. For example, mangroves. No two mangroves are really all that related to each other. Fun facts. It is a really... There's no really such thing as a mangrove. Just like there's no really such thing as a jellyfish. But I'll get into mangroves later. You came here to learn about why I swear this is not a jellyfish. So, under the common name jellyfish, there are two major phyla. And phyla is the next broadest, so down under kingdom, you've got phylum. And for the most part, I'm going to ignore kingdom because very rarely on this channel am I going to be talking about something that's not in the kingdom Animalia or animals, simply because it's really hard to get people interested in anything that's not an animal. I'll try. I'm going to be talking about kelp forests at some point because giant kelp is pretty cool actually, but I don't know, animals are cooler, which, fair enough. The two phyla that fall under jellyfish are Ctenophora, or ctenophores, which are the comb jellies. They can't really sting you. They're typically found in the deep ocean, so most people aren't really going to come into contact with them Anyway, they're also known as true jellies or true jellyfish. I don't know why that they have been given the name true jellyfish when, again, common names. So, and then there is the phylum Cnidaria. And Cnidaria is where this guy lives. There are several classes under Cnidaria. There's Staurozoa, Scyphozoa, Cubomedusa. The one that we're going to focus on is Hydrozoa, because again, that's where this guy lives. Those other classes can be pretty nasty, and I'm sure I will talk about them at some point. If you're interested in what those other classes are, leave a comment and I'll get to it sooner. So he's a Hydrozoa. Specifically, he's a Siphonophora, which is an order under the class Hydrozoa. And siphonophores are colonials. So, kind of like corals are like tiny little polyp animals that live in big colonies and build these massive skeletons. This guy is in fact not a single organism, he is many. So one of the polyps is the float. There are different kinds of polyps all throughout the tentacles, ones that focus on feeding, stinging, mating, all of that lovely stuff. And I will get more into that later. I wanted to give you a brief overview, and then I'll get into kind of the nitty-gritty about our friend the Portuguese man of war. He's got a nasty sting. But, for those of you watching this who have never seen one of these things before, you might be wondering where to find him. They can be found mostly in subtropical and tropical Atlantic and Pacific oceans. So, the tropics, everyone really knows that's that area right around the equator. The subtropical area is just north or just south of that. So, they can be found in places like Australia, Hawaii, the Caribbean, Florida, places like that. If you've lived in any of those places, I'm sure you've seen one of these things before. When I was down in Florida for my bachelor's degree, I decided to go snorkeling on a beach that had Portuguese man-of-war warnings up. It was not the smartest decision. I didn't get stung, none of my friends did, but I did swallow a lot of seawater, because it was also really rough that day. But just, as an aside, if the beach has a Portuguese man-of-war sign up, don't get in the water. Do what I say, not what I do. Gabby's done some stupid stuff. So, like most jellies, these guys are not really mobile by themselves. They just kind of sit there and float. And for that reason, jellyfish are some of the biggest plankton in the world. So they float along with the currents, and a recent study from 2020 by Canepa et al. Found that strandings of man-of-war in 2016 were concentrated on the coast of Chile, and they stung 200 people in that time and closed 120 beaches, which is not great, especially in that area, because one, Portuguese man-of-war stings are pretty rough. They're not usually deadly as long as you get treatment, but those fuckers hurt, I have been told. I have not yet been stung by any jellyfish. yet. I work in the water, it's an inevitability. They believed, the authors of this paper, that these conditions that led to this many strandings, because this many Portuguese men of war watching up on beaches is not, it's not unheard of, but it's not common. So there's that. And they believe that the conditions that led up to that were caused by the El Nino Southern Oscillation, or ENSO, which is a phenomenon in which the trade winds, so the really strong winds that go across the equator of the Earth, the trade winds in the Pacific weaken and cause a whole lot of warm water to go from the coast of Australia over to the coast of like Argentina and South America and all of that. It's this really huge, it's not really a paradigm shift, but it is a big shift in like the climates of the area. And it tends to happen on a cycle. It used to just be called El Nino, and that is just a period of warmer water. The Southern Oscillation is the change in the winds, and there has been so much evidence that those two phenomena are linked that shift has become known as El Nino Southern Oscillation, or ENSO. So if you hear me refer to ENSO later on in this video and in other videos, that's what I'm talking about. Again, if you're super interested, I can do another whole video on what the El Nino Southern Oscillation really is, but it's a lot to get into and it's very technical, and it's probably too much for this video because I do really want to focus on the man of war, because they're actually super cool even if they're not technically jellyfish, because nothing's technically a jellyfish. But yeah, so that shift was probably the cause of all of these man of war washing up on the beaches of Chile and stinging a whole bunch of people and closing all of the beaches. But out of that, they also suggested, and this is super cool, that being able to track man of war beaches and like mass movements like that could be a way to track and indicate those kinds of large-scale disturbances that are like ENSO shifts and things like that, which is just a super cool bit of science, and I'm super excited about it, and I'm really excited to see where that goes. You might not think that it's interesting, but I do. Anyway, what else do these things do other than just drift along with the currents? Because if they just drifted along with the currents, they wouldn't really be living and thriving and doing all of those things. Well, they get their food, as most Cnidaria do, by stinging. So they have nematocysts, which look like this in a Portuguese man of war, which are stinging cells, so they're little packets, and then when something brushes up against it, it triggers the nematocyst, and the nematocyst fires and releases the venom into whatever it hits. Ouch. The really fun thing about nematocysts is they're a reflex, which means even if this animal is dead, the nematocysts can still fire. So even if you see a washed up Portuguese man of war or any other kind of jelly that can sting, moon jellies are fine, calm jellies are fine, those guys don't sting. But if you find any of these things, any Cnidaria that wash up on the shore that you think might be able to sting you, don't touch it, because it can still sting you even if it's dead. Which I think is nature's just big fuck you to anyone who's too curious and wants to touch jellyfish. So, what exactly does Portuguese man of war venom do? Edward and Hessinger back in 2000 found that they they cause an influx of calcium, which is interesting. So that's what their venom, envenomation causes an influx of calcium, and what that does is it causes a breakdown of the blood cells, which is known as hemolysis. So it literally just kind of breaks your blood cells apart, which again is not ideal. You kind of want your blood cells in one piece. And that, I read that whole article, and I will post all of the articles that I have mentioned in this video will be either under this video or on the website, links that you can go read them. They're all open source. So if you're really curious and want to kind of like dive in a little bit more, you're welcome to read those articles. I read the Edward and Hessinger one, and I understood some of it, but I am not a medical student. So there was some of it that went over my head, which is unfortunate, because I would have loved to give you a little bit more detail about what exactly it does. But all I really understood of it was an influx of calcium and then hemolysis, which, I mean, I guess that's enough. It breaks your blood cells down, which is mildly terrifying, I'm gonna be totally honest. I knew Portuguese man of war venom was rough, but damn. Alright, so, I said I'd get back to it, and here I am, getting back to it. Siphonophores and their super fancy colonialism, which means that each polyp has its own job. In the case of our lovely friend, the man of war, there are 4 main polyps that do different jobs. One is very clearly the float. This is known as a nematophore. It is a type of medusoid, which just means that it looks like a jellyfish. And honestly, it looks like a jellyfish. It is just a big pocket of a polyp that is filled with gas from a gland inside of it that produces said gas and allows the organism to float along its merry way with the currents. The other 3 main types are then going to be found in the tentacles. They are all zooids, which is just another name for this type of polyp. There is a gastrozoid, which are the feeding cells. So they're going to have all of the digestive stuff and the stinging cells. So they're going to have the nematocysts in them. And I'll have a picture up here somewhere with the different types of zooids, probably. Then there are the dactyl zooids, which are the sensory ones, so they're going to feel around the environment for different things, for, currents or foodstuffs and things like that. I'm not 100% sure if this is true for the man of war, but some of the sensory organs in Cnidaria can have light sensors, so they're not true eyes, but they can sense like light and dark when like shadow crosses in front of their face. Not their face, they don't have faces. Crosses in front of the sensor. They're jellyfish, they don't have faces. They do have, I should have mentioned this when I was talking about the gastrozoids, but clearly I'm not that organized. Most Cnidaria, all Cnidaria, have an incomplete digestive system, which means that they eat and poop out of the same hole. But they don't have a brain, so they don't have to think about how gross that is. But yeah, fun facts. Tell your friends. The final one is the gonozoid. Those are the reproductive organs. So that has the sperm and the eggs and all of that jazz. There are some Cnidaria that do have internal fertilization, The Manivore are not one of them, so they do the spawning, which is they release their their eggs and sperm out into the ocean, and then hope that it meets another Manivore egg or sperm. And I do say that like it's not very effective, but clearly it is, otherwise we would not have Portuguese Manivore around, and we do. But yeah, these guys are super cool. I do one day want to get a tattoo of one of them because while I do joke and say that they are not a jellyfish, that's mostly because jellyfish is a common name and scientifically there's no such thing as a jellyfish, but it is mostly a joke. If you call it a jellyfish, we're all going to know what you're talking about. Clearly, as I have used the term several times in this video, it's just not the most accurate term, and that's fine. They are one of my favorites, and I do want to get a tattoo of one someday. But that is all I have for you guys for this video. If you want to see more from me, please like this video and subscribe to the channel, Blue Biology. This is my first video, so I'm still kind of getting used to my format and how quickly I need to talk and all of that. And I know my audio is shit, but I don't have a mic, and I'm in college, so I can't afford to buy one. But yeah, anything that you want me specifically to talk about, put it in the comments. This is Blue Biology, so it will be primarily organisms and things like that. I did say earlier in the video that I would talk about ENSO if you guys wanted to know more about it, and I will, but I'm going to fully admit that that kind of more physical aspect to the ocean is not my expertise. You do kind of have to know about it to discuss biological and ecological things happening in the ocean, because climate change is real, and I will die on that hill. But it is not my area of expertise. So if you've got anything specific you want me to talk about, let me know, and I'll do my best. If you have anything else for me, you can put it in the comments here. Reach out on any of my social media. I am at Blue Biology on Instagram and TikTok. I don't have a Twitter/X account yet, but I'm working on it. That platform overwhelms me, so Instagram or TikTok is probably going to be your best bet. Probably Instagram, because I think TikTok is weird about DMs, but yeah, that's all I have for you guys. I will see you next time. I don't know what that was. What am I doing?